Go outside on a clear night, hold a single grain of sand at arm's length, pinching it against the velvet black of the sky, that tiny sharp silhouette. It blocks your view of a patch of the universe, a patch that looks completely, utterly empty. For most of human history, we believed that was the truth, that the stars were scattered lights on a dark curtain with true nothingness in between. We were wrong. Point a powerful telescope at that empty space and wait. Let the faint, ancient light collect for hours, for days. That speck of nothing, it blooms. It resolves into a garden of light filled with thousands of glowing shapes. And those are not stars, they are entire galaxies. In 22, the James Webb Space Telescope did exactly this. It stared at a patch of sky about that size, near a cluster of galaxies called SMACS 0723. After just 12.5 hours, it sent back an image that feels impossibly crowded. It's a tapestry woven from the light of thousands of island universes, layered through space and time. A few sharp, spiky points of light in the image are stars, our neighbors, inside our own Milky Way. But everything else, every soft glow, every faint smudge, every distant pinprick, is a galaxy containing millions or billions of its own suns. And this is what the universe looks like everywhere when you have the patience to look. This idea that the dark isn't empty was once a tremendous gamble. In 1990, the director of the Hubble Space Telescope, Robert Williams, did something audacious. He used his personal discretionary time, a precious resource, to point Hubble at a patch of sky in Ursa Major chosen for a specific reason. It had almost nothing in it. No bright stars, no known galaxies. It was a blank slate. Astronomers were nervous. Many thought it was a profound waste of time. If the telescope stared for 10 straight days and saw nothing, it would be a huge public failure. For 10 days, Hubble floated in silence, its eye open to the dark. When the data came back, the silence broke. The image was not empty. It was wallpapered with galaxies. 3,000 of them, crammed into a space so small it would take thousands of those patches just to cover the full moon. That first Hubble Deep Field changed our conception of the universe. It proved that the cosmos doesn't have a backdrop. It is depths, all the way down. The darkness between the stars isn't a void. It's just a sea of light so old and so distant that our eyes, on their own, cannot register it. And so we kept looking. In 2004, Hubble stared longer at a different patch to create the ultra-deep field, revealing 10,000 galaxies. Then in 2012, astronomers combined a decade of observations on that one spot to create the extreme deep field. This was the result of 2 million seconds of exposure, 23 days of light gathering. It revealed galaxies 10 billion times fainter than anything the human eye can see. To put that in perspective, that is like standing on Earth and being able to see the light of a single candle flame on the surface of the moon. If you find a sense of calm in these deep cosmic perspectives, consider subscribing to the channel. We explore one wonder at a time without the hurry. Now let's look closer at what these images are actually showing us. In these deep portraits of the universe, you are also looking back in time. The light from the most distant galaxies has been traveling for over 13 billion years to reach us. We are seeing them not as they are today, but as they were when the universe was in its infancy. Many look messy, like chains of bright knots or chaotic clumps. These are infant galaxies still in the process of assembling. Their first generations of giant, brilliant stars are being born in violent bursts. We are, in effect, watching them learn how to be galaxies, frozen in a photograph from a time before the Earth, or even the Sun, existed. Sometimes the universe gives us a helping hand to see these ancient ghosts. In the James Webb image of SMACS 0723, there is a massive cluster of galaxies relatively close to us, only about 4.5 billion light-years away. This cluster is so heavy, its combined gravity warps the very fabric of space-time around it. Space-time itself becomes a lens. Light from much more distant galaxies, sitting directly behind the cluster, must pass through this warped space. It gets bent, magnified, and smeared into beautiful, eerie arcs of light. This isn't a flaw in the camera. It is a direct visualization of gravity at work, giving us a free boost, a natural telescope to see even deeper into the past. With this power, JWST has pushed our view back to just a few 100 million years after the Big Bang. And it has found a puzzle. Some of these very first galaxies are surprisingly bright, massive, and well-structured. It's like looking into a cosmic nursery and finding toddlers who are already as tall as adults. Our theories suggested that the first galaxies should be small, dim, and take a long time to grow. But these observations suggest that cosmic evolution might have happened much faster, or in a different way than we thought. The universe, it seems, was in a hurry to get started. So let's ask the big question. If a tiny grain of sand patch contains thousands of galaxies, how many are there in total? Let's take the Hubble Ultra Deep Field with its 10,000 galaxies as one tile. You would need over 13 million of those tiles to cover the entire night sky. If you multiply that out, you arrive at a staggering number, well over 100 billion galaxies in the observable universe. And that's just to the depth Hubble could see. A 2016 study that tried to account for the even tinier, fainter galaxies we can't yet detect estimated the true total could be as high as 2 trillion. 2 trillion galaxies. The number is so large it's almost meaningless. So let's try another way. Each of those galaxies contains, on average, millions or billions of stars. If you do the math, a conservative estimate for the total number of stars in the observable universe is something like 10 to the power of 24. That's a 1 followed by 24 zeros. It's a number that has been compared to the number of grains of sand on Earth. But it's not even close. There are more stars in our universe than there are grains of sand on all the beaches and all the deserts on our entire planet combined. By a lot. And this is the final, quiet truth that these images reveal. The sky is not a static backdrop. It is a deep ocean of time. The universe is not just out there, it is right here. Right now, as you stand on this planet, the light from those hundreds of billions of galaxies is washing over you. A constant, silent rain of photons that began their journey before humanity existed, from places we will never go. Most of it is too faint for our eyes to see, but it is there. Every empty patch of sky is in truth full of history, full of distance, full of other suns. You are standing in the middle of a museum that is 14 billion years old, and its exhibits are everywhere you look. If you enjoy these quiet journeys into the scale of everything, consider subscribing to Stardraft and leaving a like to help others find us. There are more explorations waiting for you, from the nature of black holes to the fate of the last star. Thank you for watching, and never forget what lies hidden in a patch of sky no bigger than a grain of sand.